Question number 9 has 3 parts to it. First part is just to balance the equation. You should know that the products of combustion are CO2 and H2O, both in gaseous form. The balancing now, do carbon first, 6 carbons, so I'm going to put a 6 here. Hydrogens, there are 12, I'm going to put a 6 here. This now has 12 oxygens plus 6 more, a total of 18 oxygens. There are 12 here, 6 here, which means this coefficient should be 9. Second question, yesterday's sunlight, the concept there is that this molecule, it comes from petroleum. Petroleum is oil that comes out of the ground. Petroleum. All right. And that's a fossil fuel. And fossil fuels means that this is from old plants. From old plants. And that's what yesterday's sunlight is all about. These plants absorbed sunlight perhaps 200 million years ago, and that sunlight has been trapped in the molecules, which were originally sugar molecules, but they've been transformed through geologic processes into oil, which can then be processed to make molecules like cyclohexane. So that's the concept there, and the fire that comes out when you burn it, that's the sunlight finally being released. All right, last question here is a mathematics question, 3,900 kilojoules per mole, 5.72 grams of cyclohexane. I'm hoping it makes sense to you that we should turn that into moles. 1 mole of C6H12 has a mass of 72 plus 12, 84 grams. Whoop, I did bad label. All right, so this would be a logical first step. Use my calculator, 5.72 divide by 84. 0.068 moles C6H12. This delta H value is saying that you get 3,900 kilojoules of heat from the combustion of 1 mole C6H12. Please do not put the negative sign in your calculation. This is heat. It's not negative heat. And then this is final answer, 266 kilojoules of heat. That's just about the right amount to make a pot of tea. So if you had a small amount of cyclohexane and you burned it, you could make a pot of tea with that heat.